Okay, here we have a system which is built around a physical robot, a 2 degrees of freedom system which resembles one orthosis. We have the joint, upper joint, the hip joint and the knee joint, and it is motorized by two BLDC electric motor with integrated driver, and it is commanded by the CAN bus, and the CAN bus receive the commands from the PC, which sends the commands through a serial line, and there is in the between a bridge constituted by an MCU ESP32, which reads the serial input and commands the CAN bus. The bridge is because of deterministic purposes. On the PC side, we have two processes working on two different codes. The first one is inside the CoppeliaSim environment, and as you can see is here there is a through digital twin system which resembles the physical one, and inside this model is implemented an inverse kinematic model in order to deliver the angles of the joints for a given position of the end effector. And it is possible to move inside CoppeliaSim this model by clicking and dragging the target, and the model make it possible the system follows calculating the actual angles of the joints. And then there is another code in Python environment which continuously in a loop makes queries over CoppeliaSim in order to know in real time what are the actual position of the joints, and then sends continuously to the serial port through the CAN bus to the physical system. So the physical system is able to follow what happens inside the CoppeliaSim environment. So now how it works. I start the Python code. Now it is working, and then I go to start the CoppeliaSim model. As we can see, the CoppeliaSim model goes to the actual position of the target, and the physical robot follows. In this case, we have implemented, as for the control of the motors, the MIT protocol, which is a protocol that permits to implement the impedance control. As we can see, the system performs some compliance, is compliant. Then I go here inside CoppeliaSim and I can move. I select the target, and by means of the click and drag, I will move along the Y and Z plane the end effector, and I can, with dragging, I can move inside the CoppeliaSim. As we can see, the physical robot is able to follow in a very precise and also very quick way. These are brushless motors that are very responsive. And then we can also, now we can use all the features, all the possibility inside the CoppeliaSim environment, such as, for example, to move along the vertical Z direction, like in this way. So the end effector moves along a line, vertical line. Now I put the actual the robot in near to the initial position in such a way that is not a big jump when I stop.